Right, so we're looking at ionic equations and displacement reactions. You would have already completed your do now, so I'm just going to go straight to the first slide, which is identify the ions present in each of these formulae and state how many of each ion is in the formula. So I'm going to just move over to the same worksheet that you should have as well, and the next page should be there ready for you. Right, so first of all I'm going to start with sodium chloride, and I need to first of all identify the ions that are present in each of these formula. So what I can see here is that I've got one sodium ion, I've got a sodium ion, and I've got a chloride ion. Okay, now before we actually go to step B, we also need to remember to put our charges because we're looking at ions. Remember, when we have an ion, it's not going to be neutral like an atom. So if I remember correctly, my sodium should have a positive charge and my chloride should have a negative charge. Right, let's go into our next formula. Here we have hydrogen chloride, and I can see that one ion is hydrogen, which should have a positive charge, and I have another chloride ion which should have a negative charge. Then we're going to lithium oxide, and again I have a lithium ion which will have a positive charge, and then I have oxygen, or oxide should I say, which will have a -2 charge. Right, then we have sulfuric acid. Again, I'm going to state to my ions, I have hydrogen and have a sulfate ion. And remember that if it's sulfate, it's going to have to contain oxygen. Okay, so here we have the charge, which is -2. And then finally, copper nitrate. And if I identify my ions, I have a copper ion with a +2 charge, and then my nitrate ion, which would look like so, with a negative charge. Right, section B then says state how many of each ion is in the formula. Okay, so remember we learned about our charges, but we also learned about the fact that atoms are neutral, and we learned about neutralizing ions, meaning we would have to cancel out charges or make sure that it's the same. Okay, so here I've got sodium chloride, and for every one sodium chloride, because I have the same charge here, same charge here, remember they're going to cancel each other out, so I have one sodium ion and I have one chloride ion. Yep, right. Then I have hydrochloric acid, and again I have one hydrogen ion and I have one chloride ion. Okay, now we're looking at lithium oxide, and we can see here that we've got 2 lithium atoms, but remember we want our charges to be equal or to cancel each other out, okay, to make it neutral. Remember, a compound is always neutral. An atom is neutral, and an ionic compound should also be neutral, meaning the compounds have to be neutral. So how many ions do we have of each? I should have 2 lithium ions, which should then allow my one oxygen ion. So remember, we're looking at the charges to cancel each other. So 2 of these with a positive charge will cancel out 2 negative charges to give us our neutral ionic compound. We then have sulfuric acid, and again here we can see it says H2, okay, so meaning we've got 2 hydrogen ions, and so this already shows us that it should cancel out our -2 charge on our sulfate ion. Okay, so we only have 1 sulfate ion and 2 hydrogen ions. And then finally, our copper nitrate. We have 1 copper nitrate, but we can see we've got a +2 charge, but we've only got a negative charge here. Okay, which would mean I would need 2 nitrate ions to balance out this ionic compound, copper nitrate. Yeah, so that's just some recap with what we did earlier in this topic. Let's move on to the next slide. Right, so displacement, and this is just a reminder, we've already looked at displacement again earlier on, and it said what are the word and symbol equation for this reaction. So we can see here that we've got some magnesium and we've got some copper, okay, some copper sulfate, I believe. Yes, so what would our word and symbol equation be? So we've got magnesium plus magnesium plus copper sulfate I'm just going to write this underneath just for space. Magnesium plus copper sulfate produces magnesium sulfate plus copper. Remember, we're looking at displacement reactions, yeah? And then if we just do our symbol, we know magnesium is Mg on our periodic table, plus copper sulfate, which would be CuSO4. Remember, we must have oxygen present as well, producing magnesium sulfate, which will now be MgSO4 plus copper. Right, so then what you also need to know is that this ionic equation can also be written in a different way, like so. So we now have Mg, and we're going to put our states as well, so our solid plus our copper. Remember, we're looking at ionic equations, so I'm going to put the charge here, 2 plus, and this would be an aqueous solution producing magnesium. Again, I'm putting my charge and my state plus copper, which is now solid. Now, what I want you to see is what has actually happened to the magnesium and the copper. Remember, we know we're looking at a displacement reaction, so we know, or what we can see is, if we look here, that the magnesium displaced the copper. Yeah, so it says what has happened to the magnesium and the copper. The magnesium has displaced the copper sulfate, should we say, sorry. Magnesium displaced the copper sulfate, or the copper in the copper sulfate. Right, and then it says which substance or ion or species have you noticed is missing. So, and in a moment I'll tell you what a species is. That is one of the key words. So if we look back, originally our equation was magnesium plus copper sulfate produces magnesium sulfate plus copper. But then we wrote this equation again, we wrote this ionic equation in a different way, and if you see here, we actually can't see our sulfate ion. So actually it's our sulfate ion that's missing. And we'll look at why that is a bit more as we go on. So sulfate ion is missing. Right. So if we just look at the actual word species that you just heard me say a moment ago, this is a key word that you need to get familiar with as well. So a species or chemical species is usually an atom, ion, or molecule, essentially anything that can appear in a chemical equation as the reactant or product. So if we just go back to here to this question, it said, what substance, ion, or species have you noticed is missing? Okay, and we identified the sulfate ion was missing. So that's just what we mean by the word species. Okay. Right, let's get the next slide. Okay, so what does an ionic equation actually show? So here we're looking at ionic equation. We've got magnesium plus our copper produces magnesium plus copper. What we're actually seeing here in this ionic equation is that our magnesium atom is losing 2 electrons to become that positively charged ion. Okay, and remember, whenever we lose electrons, that means oxidation is taking place. So oxidation is the loss of electrons, which we already know. And then if we look over our copper ions gain 2 electrons to also become a neutral atom, and this gain of electrons is called reduction. So remember, reduction is the gain of electrons. So if we look at the full term, a redox reaction is one where we're going to have oxidation and reduction taking place at the same time. And if you remember, I said a way you can remember this is oil rig. Oxidation is loss of electrons, and reduction is gain of electrons. So we have another type of oxidation as well in terms of actually gaining oxygen, but whenever it's in the terms of electrons, we're talking about loss of electrons or a gain of electrons. So this is the type of oxidation that we're looking at in this topic. Right, so if we look over at this table here on the next slide, I believe. Right, so let's start with hydrogen. So remember, we're looking at, it says, would A need to gain or lose electrons to become B? So first of all, we're looking at our hydrogen atom, and we want this to become an hydrogen ion. Okay, so we're going to take it back to basics and just look at what our hydrogen atom would actually look like. So we know that hydrogen typically has 1 electron on its outer shell, okay, on its energy level, right, and it only has 1 energy level. Now, so to be stable, as we know, this hydrogen atom is going to lose this electron, okay, so it's going to lose this electron and become positively charged. So remember, when we lose an electron, become positively charged. When we gain electrons, we become negatively charged. So lose electron and becomes positively charged. Okay, so it will now give us that positively charged hydrogen ion. Okay, so we've lost an electron, and how many have we lost? We know we lost 1. And if we think back to our mnemonic, oxidation is loss, reduction is gain. So because we have lost an electron, oxidation has taken place. Right, so if we look at our next one, which is sodium, so here we need to go from a sodium ion to a sodium atom. So remember, we're looking at, would A need to gain or lose electrons to become B? So to go back, we'd almost have to work backwards to go from our sodium ion to our sodium atom. If we just remember our pattern, so when it comes to our electronic configuration, we know sodium has 11 electrons. It's in group 1, which would mean it will have 1 electron in its outer shell, and it's in period 3, which means it has 3 energy levels. Okay, and without getting too confused, remember, we want to see how we would go from A to B. In A, it was the positively charged ion, but as an atom, we know that it has that electron on its outer shell. Okay, so it would gain. Okay, so how many electrons is that? Just 1. And remember, oxidation is loss and reduction is gain. So we've gained 1 here, so we have reduction taking place. So it's gone from its ion to its atom. Right, if we look at our next one, we have chlorine, and this time we have a chlorine atom going to a chloride ion. Okay, and chlorine is in group 7. Again, we can just look at our atomic structure. So we start off with chlorine, group 7, period 4, I believe. I don't know how many electrons are there in chlorine. I don't have a periodic table close to me. Let me just look over. 17, I believe. So chlorine has 17 electrons. So let's start off with our first energy level, 1, 2. Our second one, 1, 2, 3, 4, 5, 6, 7, 8. Next one, 1, 2, 3, 4, 5, 6, 7. So I'm just going to double check that. 2 in the first one, 8 in the second, 10 plus 7 is 17. 1, 2. Okay, so chlorine has 17 electrons. Right, so we want to go from our chlorine atom to our chloride ion. So the best thing that chlorine can do is gain an electron. But if you remember, typically chlorine is one of our elements that exist as a diatomic element. Okay, so if we actually look back here, we can see it says our subscript says Cl2. Okay, so Cl2, which would mean that actually I should have 2 of these. Okay, so let's just say we've drawn this out again. I have 2 of these, which means both of my chlorine atoms, which exist diatomically, so there'd be 2, would gain an electron. Okay, so it's gained an electron to become from the atom, the diatomic atom, to become the chloride ion. How many electrons did we have to gain? 2, and if you remember, reduction is gain, so reduction took place. Okay, so if we now look at copper, and we should be able to see a pattern now, but here we can see that we have a copper ion and it wants it to become an atom. We've got a positive charge here, so this means that if we want to go back to our atom, then gain would have need to take place. Okay, right, we've got 2 electrons here, so how many electrons? 2 electrons are gained for it to come back to this copper atom, and again we know that reduction is gain. And then finally, our last one, magnesium. We're going from magnesium atom to magnesium ion. Again, we don't really need to draw it out again. Hopefully by now you can understand the pattern. We know that magnesium is in group 3, similar to sodium. So we know magnesium is in period 3, similar to sodium, group 2. So it should only have 2 energy levels and 12 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, sorry, period 3, so it should have 1 more. Yep, and we want to go from a magnesium atom to a magnesium ion. So this magnesium atom is going to lose these 2 electrons to become positively charged. Okay, it becomes that positively charged ion, but it lost 2. So here we've got, it loses electrons. How many electrons did it have to lose? 2. I mean, oxidation is lost because we lost those electrons. Okay. What you should have in the record as well, I've just given you a list of common ions. You don't always need to know them off by heart, but if you just get yourself familiar with them, the different ions, and that should help you, along with what I've just shown you, to help you fill in this table that we've just done together. Right, so let's go on to our next page, and we are still looking at writing ionic equations. So here it says, okay, let's get a bit closer. Here it says, the ionic equation for the reaction between zinc and hydrochloric acid is as follows. Zinc reacts with hydrochloric acid to produce hydrogen gas and zinc chloride. It says, write an ionic equation for this reaction. Okay, so if you remember earlier, we looked at this in a moment. I'm going to show you shortly how we really can break this down. So the ionic equation for this would be zinc, and we're going to put our state as well, plus hydrogen, okay, and we've got 2 hydrogens producing hydrogen, which is now gas. So we've gone from a hydrogen ion to a hydrogen atom, which is now gas, and zinc. Okay, and we're going to put, which is now aqueous. Now it says, explain which species has been reduced in this reaction. Okay, now as you can see here, we can no longer see our chlorine. Okay, so this shows us that it's our hydrogen that has been reduced. Okay, because our hydrogen has gained electrons. So hydrogen is reduced in this reaction because it gains electrons. Yeah, so we look here again, hydrogen has been reduced because it's gained electrons. Okay, let's go to our next one. So here we have copper plus silver nitrate produces silver and copper nitrate. So we're going to write our ionic equation for this. So here we have copper, which is in its solid state, plus silver, and we have two silvers. We're going to put our positive charge, which is aqueous at this point, produces silver and copper. So here it says which species is oxidized. So remember, oxidation is loss, reduction is gain, and here we can see copper has lost. Okay, so copper is oxidized because it has lost electrons. So copper is oxidized because it loses electrons. Okay, right, so we're going to look now as to why we lose some of these species. So I'm going to introduce these spectator ions. And spectator ions are ions that are present during the reaction but are unchanged by the reaction, and so are present in the same state on both sides. Okay, so if you just give me a moment. Okay, right, so here, zoom in. Or should I write it on here? Is it a bit clearer? Yeah, I'll do it from here. But you guys can do it here, but I'm going to just write it onto here. Yep. Okay. So, it says, look at the chemical equation. Magnesium plus copper sulfate produces magnesium sulfate plus copper. We can use two steps to write this as an ionic equation. Okay, so first of all, it says split up the aqueous substances into their ions. Right, so the way we can do this, so we're splitting this into its ions. We're going to have magnesium, which is in its solid state, plus copper. Now, remember, we're splitting up the aqueous, so here, substance into its ion. So we should be able to get a copper ion and a sulfate ion from this. So copper, and this aqueous, plus now our sulfate ion. So SO4, and we know sulfate has that -2 charge, and it's still aqueous. Okay, to produce magnesium, so we're going to have a magnesium ion, which will have a +2 charge, which is aqueous. And then remember, we've got a sulfate ion here as well, plus sulfate, a +2 charge, and copper, which is solid. Right. It then says delete the spectator ions. So remember, if we just go back here, we know spectator ions are ions that are present during the reaction but are unchanged by the reaction and are present in the same state on both sides. So if we look here, we have sulfate, our sulfate ion present in our reactants, and sulfate ion present in our products, also in the same state, aqueous and aqueous. So what this means is that we can actually get rid of these spectator ions. Yeah, so once we get rid of these spectator ions, and if we rewrite this ionic equation, what we should have now is magnesium plus copper, so So remember, still an ionic equation. So we've got our charge plus copper, which is aqueous, produces a magnesium ion and copper, which is our solid. Yeah, so this is how we're actually able to go from the first full equations we've been able to see to splitting it up into its ions, getting rid of the spectator ions, so the ones that appear the same on both sides, and then having this type of ionic equation as well. Okay. Right, so let's do some more practice. If you go to the next page of your worksheet, it's a taught task /redo. It says, write an ionic equation for the chemical reaction below. So here we can see sodium reacts with copper oxide to produce sodium oxide and copper. Okay, so we know the steps that we need to take. We want to rewrite this equation, separating all of the ions, all of the substances into their ions, and then remove any spectator ions. Okay, so what we should have is sodium plus copper plus oxygen. And remember, you can use your ions, the list of ions, the common ions that I gave you earlier on to help you. You don't necessarily have to remember them off by heart. If you do, that's good. So sodium plus copper, and here we can see it's aqueous, plus oxygen, and we know the charge in an oxygen ion is -2, still aqueous, to produce sodium, which is aqueous, oxygen ion again present here, a -2 charge, also aqueous, and copper. Right, so if I look here, I want to get rid of my spectator ions. So remember, my spectator ions are the ions that are present on both sides and in the same state. So here I can see I have oxygen, or my oxygen ion, oxide ion here, present in the aqueous state in my reactants, and I also have it in my products. Okay, so that's my spectator ion. Now, once I've gotten rid of that spectator ion, I could then write the ionic equation, which will now be sodium. So remember, we've got put our solid here. I've only got it from there. Plus copper, which we know is aqueous, to produce sodium and copper. Right, so it then says, discuss which species is oxidized and which is reduced. Okay, so remember, oxidation is loss, reduction is gain. So when we look at this ionic equation, which species gained electrons and which species lost electrons? So when I look here, I can see that sodium has had to lose electrons. Okay, so sodium has been oxidized. So sodium is oxidized, so because it's lost electrons, because it loses electrons. And then we look at copper. Copper's had to gain electrons. Okay, so copper is reduced, because it gains electrons. Okay. Right, so I want you to attempt the you-do by yourself. You can use the list of common ions to help you if you need help. Go back and look through the steps. You have to write an ionic equation for this reaction. Remember, you need to identify the spectator ions that should help you to get the final ionic equation, and then you need to identify in this question which species was oxidized. And remember, oxidation is loss.